All right, today we're going to take a tour of one of the most powerful and fascinating factories inside the human body, the adrenaline assembly line. We're going to break down exactly how this incredible chemical gets built, from the simplest raw material all the way to the finished product. So let's dive in. You know that feeling, right? Maybe you're about to give a speech or a car cuts you off in traffic. All of a sudden, your heart starts pounding, your senses feel razor sharp, and you get this incredible surge of energy. That's the adrenaline rush. But what is that, really? And where on earth does that feeling come from? Well, to answer that, we have to go right to the source. We're heading straight into the factory that makes it all happen. And here they are. If you could look deep inside your body, you'd find these small but seriously mighty structures sitting right on top of each of your kidneys. These are the adrenal glands. You can think of them as the main headquarters, the command and control center for your body's entire stress response. Okay, so now let's zoom in even further. We're going from the main building right down to the specialist workshop on the factory floor, the adrenal medulla. So, the very core of this factory is the adrenal medulla. And what's so cool is its origin story. It's actually built from the exact same embryonic cells that also create parts of your nervous system. That tells you something huge right away. This gland is fundamentally hardwired into your body's electrical grid from the very beginning. And if you look at what this workshop is cranking out, you can see it's super specialized. It produces two main hormones, but the undisputed star of the show is epinephrine, which is what we all call adrenaline. It makes up a whopping 80% of the total output. The other 20% is its close chemical cousin, norepinephrine. Together, these guys belong to a chemical family called the catecholamines, and they are fascinating because they really play two different roles in the body. They act as hormones when they travel through the bloodstream, carrying messages far and wide. But they also work as neurotransmitters, zapping messages directly between nerve cells. They are the body's ultimate rapid response messengers. So, now that we know where adrenaline is made, let's get to the really cool part, how it's made. It's time to step onto the catecholamine assembly line and see the whole process. Believe it or not, every single molecule of adrenaline your body ever makes starts its life as this one simple thing, tyrosine. It's an amino acid, a basic building block that you get from the protein in your diet. This is the raw material that gets delivered to the factory floor. The production process is a four-step chemical conversion. First, our raw material, tyrosine, gets turned into a molecule called dopa. Next, dopa is transformed into dopamine. Yep, the famous feel-good neurotransmitter. From there, dopamine gets converted into norepinephrine. And in the final step, norepinephrine is modified to become the finished product, epinephrine, or as we know it, adrenaline. Of course, these transformations don't just happen on their own. Each step on this assembly line is run by a highly specialized worker, an enzyme. Tyrosine hydroxylase kicks things off. Then dopa decarboxylase takes over. It's followed by dopamine beta hydroxylase. And finally, a very specific enzyme called PNMT comes in to complete that last conversion to adrenaline. Okay, so we've got our factory and we've got our assembly line all mapped out. But what gives the order to fire it all up? Let's trace the signal that gets this whole operation going. The triggers are probably going to sound pretty familiar to you. The factory gets the go signal in response to things like psychological stress, a big deadline at work, or intense physical activity like a hard workout, or even an internal signal like your blood sugar dropping too low. All of these are signs telling your body to get ready for action. And the chain of command here is incredibly fast. First, a part of your brain called the hypothalamus detects one of those triggers. It immediately activates the sympathetic nervous system, which sends lightning-fast nerve signals directly to the adrenal medulla. And in an instant, the adrenal medulla gets the order and releases all those hormones straight into your bloodstream. So once adrenaline is out there cruising through your bloodstream, it doesn't just affect every cell it bumps into. No, it acts like a key, and it's searching for very specific locks. These locks are called adrenergic receptors, and they're basically docking stations located on the surface of target cells all over your body. Now, here's where it gets really clever. There isn't just one type of lock. There are two main classes, alpha and beta receptors, and they work differently. Alpha receptors tend to work by increasing calcium inside the cell, while beta receptors increase a different messenger called CAMP. This is how a single hormone, like adrenaline, can have totally different effects in different parts of the body, like making some blood vessels tighten up while telling others to relax. It's an amazing system. So we've seen the factory, the assembly line, and the delivery system. Let's put it all together and ask the big question. Why does this chemical matter so much? Well, it's all about activating the body's high alert system. This entire intricate process exists for one main reason: to instantly prepare your body for immediate intense action. We're talking about getting you ready for peak physical performance in a matter of seconds. It's the biological foundation of that classic fight or flight survival response. And that brings us to a final, really crucial question. This whole system, this fight or flight response, is an ancient survival circuit. It evolved to save us from immediate life-threatening dangers, like a predator. But today, it often gets triggered by work deadlines, traffic jams, and social media notifications. So we've got to ask ourselves, is this ancient survival circuit really a good fit for the chronic, non-stop stresses of our modern world? That's definitely something to think about.